I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. Before us, a typical chemistry A-level question on chemical equilibrium. One molecule of hemoglobin, Hb, can bind with 4 molecules of oxygen according to the following equation. From the equation, 1 mole of Hb, which is hemoglobin, plus 4 moles of oxygen react to give you 1 mole of oxide of hemoglobin. When the equilibrium concentration of oxygen is 7.6 times 10 raised to the power minus 6 moles per dn cube, the equilibrium concentrations of Hb and oxide of Hb are equal. What is the value of Kc for this equilibrium? Kc is the equilibrium constant. Now, from the equation, we are given the concentration of oxygen. We are given the concentration of oxygen. We are given the concentration of oxygen, which is 7.6 times 10 raised to the power minus 6 moles per dn cube. Then the concentration of hemoglobin and the oxide of hemoglobin are equal. So from the equation, the equilibrium concentrations of Hb and the oxide of Hb are equal. Let's assume that we don't know. So Hb, we don't know the concentration. So let's assume that the concentration is equal to X, because concentration of Hb is equal to X. So if the concentration of Hb is equal to X, the concentration of the oxide of Hb, which is hemoglobin, will be equal to what? X also. So if we write down the equilibrium constant Kc will be equal to what? Concentration of what? The oxide of hemoglobin, HbO2, divided by the concentration of what? Hemoglobin, multiplied by the concentration of oxygen, all raised to the power 4. Raised to the power 4. So if we write the equilibrium constant Kc, the equilibrium concentration of the oxide of hemoglobin is X, we assume to be X. The equilibrium concentration of hemoglobin is X, multiplied by the equilibrium concentration of oxygen is 7.6 times 10 raised to the power minus 6, all raised to the power 4. So X cancel X. So we'll now have equilibrium concentration will now be, equilibrium constant will now be 1 over 7.6 times 10 raised to the power minus 6, all raised to the power 4. So if I'm to use my calculator, which will now be 1 divided by 7.6 times 10 raised to the power minus 6, all raised to the power 4. So it will now be equal to what? So what we'll have here will be equal to 3.0 times 10 raised to the power 20. 3.0 times 10 raised to the power 20. So the correct answer to this question is what? A, which is 3.0 times 10 raised to the power 20. So it's as simple as what? A, B, C. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. Before us, a typical chemistry A-level question on chemical equilibrium. An aqueous solution was prepared containing a mixture of 1.0 mole of silver nitrate and 1.0 mole of iron 2 sulfate in 1.00 dm cube of water. When equilibrium was established, there was 0.44 mole of silver ion in the mixture. Now the equation, 1 mole of aqueous silver ion reacts with 1 mole of aqueous iron 2 sulfate to give you 1 mole of silver solid plus 1 mole of iron 3. So what is the numerical value of Kc, which is the equilibrium constant? So from the question, we are given the initial moles. So let's write down the initial moles of each of the reactant and the product. So initial mole for silver, which is silver nitrate, is 1. Initial mole for iron 2 is 1. Initial mole for iron 3 is 0. So since silver is solid, the concentration of solid does not change. So it will not appear on the equilibrium expression. So the concentration of the solid do not change during the reaction, remains constant. So it will not appear on the equilibrium expression. So we have to ignore that. We don't need to bother ourselves about that. Then now we have to calculate the equilibrium moles of each of the reactant and the product. So this is the equilibrium mole. Let's calculate the equilibrium mole. From the question, when equilibrium was established, there was 0.44 moles of silver ion in the mixture. So at equilibrium, we have 0.44 moles of silver ion at equilibrium. So we have to calculate the number of moles of ion 2 and what? Ion 3. Equilibrium moles of ion 2 and ion 3. That's what we have to calculate, and the equilibrium moles of ion 2 and ion 3. So if 0.44 moles of silver ion is left at equilibrium, how many moles of silver ion must have reacted? Which is 1 minus what? 0.44. So 1 minus 0.45, I'm to use my calculator. 1 minus 0.44, so you have 0.56. That means 0.56 moles of silver ion must have reacted. 0.56 moles of silver ion must have reacted. So we need to calculate the moles of ion 2 and ion 3 that's left at equilibrium. So if you looking at the stoichiometry, if 1 mole of silver reacts, 1 mole of silver ion reacts, and 1 mole of ion 2 will also react. So if 0.56 moles of silver ions react, how many moles of ion 2 will also react? So it will be 0.56. So if 0.56 moles of ion 2 must have reacted, how many moles of ion 2 will be left at equilibrium? Which is 1 minus what? 0.56. So let me use my calculator. 1 minus 0.56. So you have 0.44. 0.44 moles of ion 2 must have reacted. Now let's calculate the number of moles of ion 3 at equilibrium. Now, from the stoichiometry again, 1 mole of silver ion reacts, 1 mole of ion 3 is formed. So when 0.56 moles of silver ion reacts, how many moles of ion 3 will be formed? X is equal to what? 0.56. So at equilibrium, we'll have 0.56 moles of ion 3 ions. So I have to erase this so that I will have enough space. I have to erase this so that I'll have enough space. So for silver ion, so this is the equilibrium mole, 0.56. So for silver ion, the equilibrium mole for silver ion is 0.44. The equilibrium mole for ion 2 is also 0.44. Then the equilibrium mole for ion 3 ion is 0.56. So equilibrium expression Kc will be equal to what? Concentration of what? Ion 3 divided by what? Concentration of silver ion multiplied by concentration of what? Ion 2 ion. So yeah, the concentration of solid silver will not appear on the equilibrium expression because it's a solid and the concentration remains constant, do not change during the course of the reaction. So it will not appear on the equilibrium expression. So having gotten the equilibrium moles of each of the reactant and the product, we have to insert it on the equilibrium expression. So I have to erase so that I will have enough space. Let me erase this. So I'll have enough space. So the equilibrium constant Kc because of concentration of ion 3, which is 0.56 divided by 1, which is concentration, which is the volume, over 0.44 over 1, which is the concentration, times 0.44 over 1, the volume, which is 1 dm3. So I have to calculate now. So I'll use my calculator. So have 0.56, 0.5, 0.44, 0.56 divided by 1, you have 0.56 divided by 0.44 divided by 1 times 0.44 divided by 1, which is equal to 0.1936. So I have to calculate now. 0.56 divided by 0.1936 So you have 2.89, 2.892. So the correct answer to this question is what? D, which is 2.89 approximately. So the correct answer is what? D. So the numerical value of Kc is 2.89, which is what? D. So it's as simple as ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. Before us, a typical chemistry A-level question on chemical equilibrium. At a total pressure of 1.0 atm, which is atmosphere, that nitrogen tetroxide is 50% dissociated at a temperature of 60 degrees Celsius, according to the following equation. From the equation, 1 mole of dinitrogen tetroxide dissociates to give you 2 moles of nitrogen dioxide. What is the value of the equilibrium constant Kp for this reaction at 60 degrees Celsius? So the first thing we need to do is to write the initial moles of the reactant and the product. So from the question, we are given that 50% of dinitrogen tetroxide has dissociated. So dinitrogen tetroxide is 50% dissociated. That means 50% of dinitrogen tetroxide has reacted, and 50% is half. That means half of dinitrogen tetroxide has dissociated. So initial mole for dinitrogen tetroxide is 1, and here is 0. Now let's get the equilibrium mole. So if 50% of dinitrogen tetroxide are dissociated, which is half, so what will be left at equilibrium is 1 minus half, which is equal to half. That is the equilibrium mole for dinitrogen tetroxide. Then we'll have to get the equilibrium mole for nitrogen dioxide. So from the stoichiometry, 1 mole of dinitrogen tetroxide dissociates to form 2 moles of nitrogen dioxide. Then half moles of mole of dinitrogen tetroxide dissociate. What moles of nitrogen dioxide will be formed? So you cross multiply. X now will be equal to what? Half times 2, which is equal to what? 1. So 1 mole of nitrogen dioxide will be formed at equilibrium. So the equilibrium mole for nitrogen dioxide is 1. So I have to calculate the mole fraction of each of them so that I can calculate what the partial pressure to enable me to calculate the Kp. And you know, partial pressure is total pressure times mole fraction. We have the total pressure, which is 1.0 atmosphere. So I have to erase so that I'll have enough space to calculate. So the mole fraction for nitrogen, the nitrogen tetroxide will be equal to what? Half divided by what? Half plus 1. So I'm to use my calculator. So I have to calculate this. This is LCM here is 2. 2 into 2, 1 times 1 plus 2 into 1, 2. 2 times 1, 2. So it will be 3 over 2. So the mole fraction now will be equal to mole fraction of N2O4 will be equal to what? 1 over 2 divided by 3 over 2, which is equal to 1 over 2 times 2 over 3. So it will now be equal to what? 2 times 1, 2. 2 times 3, 6. 2 over 6, which is equal to 1 over 3. 2 here 1, 2 here 3. So the mole fraction for what? Mole fraction for dinitrogen tetroxide is equal to what? 1 over 3. So I have to calculate the mole fraction for dinitrogen nitrogen dioxide. So the mole fraction for nitrogen dioxide will be equal to what? 1 divided by 3 over 2, which is 1 over 2. Let me erase this so that I'll have enough space, which is 1 over 2 plus 1, which is equal to 1 divided by 3 over 2, which will now be equal to 1 times 2 over 3, which is equal to 2 over 3. That is the mole fraction for nitrogen dioxide. Mole fraction for nitrogen dioxide is equal to what? 2/3. So I have to erase so that I will have enough space. So I erase the whole of this. So that I'll have enough space. So the next thing to do is to calculate the partial pressure. So the partial pressure is total pressure times mole fraction. So partial pressure for dinitrogen tetraoxide will be equal to what? Total pressure times mole fraction. The total pressure is 1 times the mole fraction is 1/3, which is equal to 1/3. Partial pressure for nitrogen dioxide, which is equal to total pressure 1 times the mole fraction, which is 2/3, which is equal to 2/3. So let me erase this for space so I can calculate the value of the Kp since I've gotten the partial pressure. So Kp will be equal to what? Partial pressure of what? Nitrogen dioxide, all raised to power 2, divided by partial pressure of dinitrogen tetraoxide, which will now be equal to 2/3, all raised to power 2, divided by 1/3, which will now be equal to 2/3 raised to power 3 is equal to 4/9, divided by 1/3, which will now be equal to, I have to erase for space, Kp now will be equal to 4/9. You change the division sign to multiplication times 3/1. So which will now be equal to 3 here, 1, 3 here, 3, which is equal to 4/3 atmosphere. So that is the correct answer to this question. So the value of the equilibrium constant Kp for this reaction at 60 degrees Celsius is 4/3 atmosphere. So the correct answer to this question is what? C. C is the correct answer, which is 4/3 atmosphere. So it's as simple as what? A, B, C. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. Before us, a typical chemistry A-level question on chemical equilibrium. What is the correct expression for Kc for the reaction shown? So you're asked to give the equilibrium expression for Kc for the reaction shown. So from the reaction, 1 mole of aqueous iodine reacts with 2 moles of aqueous ion 2 sulfate to form 2 moles of iodide ions plus 2 moles of ion 3. So equilibrium expression, if you have to write the equilibrium expression Kc, equilibrium constant is the product of the concentration of the product raised to the power of the number of moles divided by the product of the concentration of the reactant raised to the power of the number of moles. I repeat again, equilibrium constant is the product of the concentration of the products raised to the power of the number of moles divided by what? The product of the concentration of the reactant raised to the power of what? Number of moles. So equilibrium expression Kc will be equal to what? Concentration of what? Iodide ion raised to power 2 multiplied by concentration of what? Ion 3 raised to power 2 divided by concentration of what? Iodine multiplied by concentration of ion 2 all raised to power 2. So as you can see, this is the equilibrium expression. Okay, this is the correct expression for equilibrium constant Kc. So it's as simple as what? A, B, C. So the correct answer to this question is what? B. B is the correct answer. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. Before us is a typical chemistry A-level question on chemical equilibrium. When copper is added to a solution of silver ions, the following equilibrium is established. 1 mole of copper solid reacts with 2 moles of silver ions to give you 1 mole of copper 2 ions and 2 moles of silver solid. The equilibrium concentration is equal to 1.0 times 10 raised to the power 5. What is the concentration of silver ions at equilibrium when copper 2 ion concentration is equal to 0.1 mole per dm cube? Now, if you look at the reactant and product, we have 1 mole of copper solid and 2 moles of silver solid. Now, the concentration of solid does not change during the course of a reaction. The concentration of solid remains what? Constant. So hence they don't appear on the equilibrium expression. Yeah, they don't appear in the equilibrium expression because the concentration of solid do not change in the course of a reaction. So the first thing we're going to do, we're going to write the equilibrium expression. So the concentration of copper solid and silver solid will not appear on the equilibrium expression. So Kc, equilibrium expression Kc will be equal to what? Concentration of copper 2 ion divided by concentration of silver ion all raised to power 2. So the equilibrium concentration is 1.0 times 10 raised to power 5 will be equal to what? Concentration of copper 2 ion is 0.10 divided by concentration of silver ion so we cross multiply. So 1.0 times 10 raised to power 5 concentration of silver ion will be equal to 0.110. So concentration of silver ion all squared will be equal to 0.1 divided by 1.0 times 10 raised to power 5. So I'm to use my calculator. So I will have 0.1 divided by now it will now be equal to 1 times 10 raised to power minus 6. 1 times 10 raised to power minus 6. So I have to erase this so that I'll have enough space. So let me erase this so that I'll have enough space. So concentration of silver ion all squared will be equal to 1 times 10 raised to power minus 6. So concentration of silver ion will now be equal to square root of 1 times 10 raised to power minus 6. Let me erase this so I'll write it properly. 1 times 10 raised to power minus 6, which will now be equal to, so I'm to use my calculator. Square root of so you have 0.001, which is equal to 1.0 times 10 raised to power minus 3 mole per dm cube. So the correct answer to this question is C, which is 1.0 times 10 raised to power minus 3 mole per dm cube. So that is the correct answer to this question. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. Before it's a typical chemistry A-level question on chemical equilibrium. Ethyl ethanoate undergoes the following reaction. 1 mole of ethyl ethanoate reacts with 1 mole of water to give 1 mole of ethanol plus 1 mole of ethanoic acid. Equal amount of ethanoic acid and ethanol were mixed together and allowed to reach equilibrium. At equilibrium, the concentration of both ethanoic acid and ethanol were 0.42 mole per dm cube. What is the concentration of ethyl ethanoate at what? At equilibrium. So the first thing to do is to write the equilibrium expression. So Kc, equilibrium expression Kc will be equal to what? Concentration of ethanol, C2H5OH, multiplied by concentration of ethanoic acid, divided by the concentration of ethyl ethanoate, multiplied by the concentration of water. So at equilibrium, the concentration of both ethanoic acid and ethanol were 0.42 mole per dm cube. So we have the concentration of ethanol and ethanoic acid, and we are given the equilibrium constant. So we have to calculate the concentration of ethyl ethanoate at equilibrium. Now, if you look at the stoichiometry of the reaction, 1 mole of ethyl ethanoate, when 1 mole of ethanoic acid reacts, 1 mole of water reacts. So we have equal moles of what? Ethyl ethanoate and water. So we don't know the concentration of ethyl ethanoate. Let's assume the concentration of ethyl ethanoate to be X. So the concentration of water will also be X mole per dm cube, since we have the stoichiometry 1:1. So we have to calculate what? The concentration of ethyl ethanoate at equilibrium. The equilibrium constant Kc 0.27 will be equal to what? Concentration of ethanol is 0.42 multiplied by concentration of ethanoic acid 0.42 divided by the concentration of ethyl ethanoate is X multiplied by the concentration of water is also what? X. So 0.27 will be equal to, I'm to use my calculator, 0.42, 0.42 you have 0.1764. 0.1764 divided by what? X as X is X squared. So when you cross multiply, so I'm to erase so that I'll have enough space. I have to erase this so that I'll have enough space. So when you cross multiply, you now have X squared will be equal to what? So let me erase this. 0.27 X squared will be equal to 0.1764. So X squared now will be equal to 0.1764 divided by 0.27. So I'm to use my calculator. 0.1764 divided by 0.27. So you have X squared will be equal to 0.65333. So X now will be equal to what? Square root of 0.65333. Square root of 0.6533. So square root of 0.65333. So you have 0.8018 mole per dn cube. Mole per dn cube, which will be approximately what? 0.81. So the correct answer to this question is what? C. C is the correct answer, which is 0.81 mole per dn cube. So it's as simple as ABC. Attempt as many questions as possible. and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. Before it's a typical chemistry A-level question on chemical equilibrium. Hydrogen and carbon dioxide gases are mixed at 800 Kelvin. A reversible reaction takes place. 1 mole of hydrogen reacts with 1 mole of carbon dioxide gas to give you 1 mole of water and 1 mole of carbon monoxide. At equilibrium, the partial pressures of hydrogen and carbon dioxide are both 10.0 kilopascal. Kp is 0.288 at 800 Kelvin. What is the partial pressure of carbon monoxide in the equilibrium mixture? So the Kp is the equilibrium constant in terms of partial pressure. So I have to write the equilibrium expression. That's the first thing. Kp is equal to partial pressure of water, which is the product, multiplied by partial pressure of carbon monoxide, divided by partial pressure of hydrogen, multiplied by partial pressure of carbon dioxide. Now we are told that at equilibrium, the partial pressure of hydrogen and carbon dioxide are both 10.0 kilopascal. So Kp is 0.288. So the partial pressure of hydrogen and carbon dioxide are the same, which is 10.0 kilopascal. So what is the partial pressure of carbon monoxide in the equilibrium mixture? Now, if you look at the equilibrium, if you look at the stoichiometry, the equilibrium reaction, look at the stoichiometry of the product, which is water and carbon monoxide. 1 mole of carbon monoxide is formed. When 1 mole of water is formed, 1 mole of carbon monoxide is formed. So we don't know the partial pressure. We want to calculate the partial pressure of carbon monoxide. Let's assume that the partial pressure of carbon monoxide is X. So the partial pressure of water will also be X, because since the mole ratio is 1:1. So we assume that the partial pressure of carbon monoxide and the partial pressure of water is X. So to write the equilibrium expression, so we have to solve the calculation now. The Kp is 0.288. 288 is equal to partial pressure of water. We assume that it is X, multiplied by partial pressure of carbon monoxide. We don't know X, divided by partial pressure of hydrogen is 10, times partial pressure of carbon dioxide is also 10. So this one now will be equal to 0.288 will be equal to X squared. X and X squared divided by 100 over 100. So I have to erase so that I'll have enough space. So I'll just have to erase this. So we now have 0.288, which will be equal to X squared over 100. So when you cross multiply, X squared now will be equal to 0.288 times 100. So X squared will be equal to, I'm to use my calculator, 0.288 times 100 will be equal to 28.8. X now will be equal to square root of 28.8, which will now be equal to square root of 28.8, which will be equal to 5.366, which will now be equal to 5.37 kilopascal approximately. So 5.37 kilopascal approximately. So the correct answer to this question is A. A is the correct answer, which is 5.37 kilopascal. So as you can see, it's as simple as ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.